Right. Good morning to all. I'm Dr. E. Sanjeev Raidu, Associate Professor, Civil Engineering Department, G. Pullareddy Engineering College. Deals environmental engineering subject. In olden days, this name is called Public Health Engineering. Public Health Engineering deals water supply engineering and sanitary engineering. Later, this name changed. Environmental engineering is a globally. It deals water supply, sanitation, air pollution, noise pollution, environmental impact assessment. What is environment? Environment means its surrounding or surrounding. Is a very broad term generally. It includes all things that is above, below, around us, be it air, water, plant, and animal life. So one of the pictures shows our environmental. This is one type environment. Is the right environment. So what is difference between environment science and engineering? Science searching theory, engineering searching process. Is engineering deals planning, designing, and execution. Science only searching for theory. This environmental engineering deals all this one, right? Water supply, water, wastewater, solid waste, industrial waste, air pollution, noise pollution, environmental impact assessment. In water supply engineering, there are some terms. One is potable water, palatable water, wholesome water, distilled water, polluted water, contaminated water. Right. Potable water means is a fit for drinking water. Wholesome water means is water within the limits of standards that fit for drinking. And palatable water is a good water whenever looking aesthetically is good, whenever drinking we feel some pleasant. That water is known as palatable water. Distilled water is pure water but not suitable drinking water. When consume distilled water, some minerals are dissolving in our body that loss our body some minerals. This is a polluted water is polluted by various kinds of waste. So like contaminated water is also unfit for drinking purpose. So in water supply engineering, there are some course outcomes. One is estimate water demand based on in city needs, any town or city needs, various purpose, right? Domestic, industrial, or commercial, like that. And next course outcome, what is right? Various sources of water available, and what about quantity and quality. Next, how to distribution of water to the town or city based on various networks or cross method, like that. And see course outcome 5, what is right? Understand different aspects of air and noise pollution. This is right in our syllabus. It's going right. First unit, what is the need for protected water supply for society? If not supplied protected water, what are the various waterborne diseases and effects? And come to right quantity of water, design, population forecasting, rate of consumption for various purpose, fluctuations in demand, what are the factors governing in fluctuations in demand, and fight demand. And unit 2 is about quality of water and sources of water. Unit 3 is this unit 2 in unit 2 and what is intake structures and types of conduits. Unit 3 completely treatment of water for domestic point of view, various kinds of treatments like aeration, sedimentation, coagulation, filtration, disinfection, and extra. And distribution system, what is systems of water supply, layout of water distribution system, and mass curve application for designing of overhead tank, and various kinds of valves and fire hydrants, and distribution by network analysis or the cross method. Unit 5, that's a basic concept of air pollutions and noise pollutions, and what is the sources and their impacts, how to write control this, right? Come to write on water supply engineering, first unit, right? This, right, already explained, potable water, purified water, mineral water. So the main difference between pure water and minerals water, pure water means undesirable minerals removing from the water. Mineral water difference, after purifying, required quantity of minerals added to the water that is fit for drinking and good for health point of view. And this, right, contaminated, like this, right, flow chart for water supply system. In this flow chart, first sources of water. In sources of water, two types, surface sources and subsurface. And surface, various ponds, rivers, reservoirs, and oceans. And this water is collected and treated and distributed to the public. And subsurface, springs and wells, this, right, is directly collected and treated and directly distributed to the consumers. This, right, is just a flow chart of water supply system. So, need for protected water supply system. What is need to supply public protected water? Because if not supplied, right, generally water contain are the source various types of impurities. The presence of impurities in water beyond the tolerance limits that may affect the health of the public when if consumed without any treatment of water. So the reason, what is polluted main reason, the following are the reasons. One is indiscriminate disposal of untreated wastewater into the sources, like into the rivers or ponds, whatever, right, without any treatment, directly disposal. And disposal of industrial wastewater without proper treatment. And when rainwater percolated through ground, the water is dissolves various minerals that may cause hardness and fluoride and alkalinity. These are the results groundwater polluted. And the chemical impurities like fluoride, nitrate, beyond the tolerance limits, it causes fluorosis and methemoglobinemia diseases like blue baby syndrome. The bacteria present in water, like especially pathogenic, that may cause waterborne diseases like typhoid, cholera, and dysentery. Hence, it's necessary the water is properly treated before supply to the public, right? Compulsory. And that is it. What are the objectives, main objectives of water supply system? One is main, how to remember 4 points: quantity, quality, cost, and distribution. These 4 very important. So first one, to supply safe and wholesome water to the public. And second thing, to supply sufficient quantity of water to the public. And third one, to distribute the water at every convenient points by establishing a good layout of network of underground system, water grounds. To supply at reasonable cost, that is maybe to encourage the household hygienic, right? That is a very important cost. Finally, these 4 points is the objectives of water supply system. So quantity, quality, distribution and cost. Yes. And waterborne diseases and their control, that is right, main waterborne diseases. This is through the contaminated water. This contaminated mainly various causes. One is presence of right microorganisms, presence of parasitic ova, presence of inorganic matter, presence of organic matter. These main four contaminated main causes waterborne diseases. One is presence of microorganism. These three very important: bacteria, virus, and protozoa. And disease causes by the bacteria. In case bacteria presence in water, especially that is right. E. coli, lycode, paratype, right? This bacteria main causes diseases: typhoid, first one, paratyphoid, cholera, and bacillary dysentery, diarrhea of travelers. These are the main causes of diseases by the bacteria. This one. And disease causes by the viral infection, one is jaundice. That is the main, many people is affected, especially in rainy season, because of this virus. That is another one, poliomyelitis, that is called poliovirus bacteria, and infectious non-bacterial gastroenteritis, another diseases, right? Is a come to protozoa. This protozoa main is amoebiasis, that is the diseases, and cryptosporiasis and giardiasis. This is the main diseases due to the protozoa microorganisms. And some parasitic ova, mosquitoes and some worms, right? Egg worms of roundworms. These are generally created in water. That is main diseases: flukes, guinea worm, hookworm, and malaria yellow fever. That is nice. Flukes, main right, that is caused by roundworm and tapeworm. Guinea worm caused by roundworm and tapeworm. Hook, that is also same, and malaria is main causes due to the mosquitoes eggs, presence of mosquitoes eggs. And diseases caused by inorganic matter. This some minerals presence, right, excess that may cause severe damage, and absence, that is another problem. For example, fluoride, absence of fluoride in water, that may cause cavities is formed on young children, especially young children. And excess fluoride, that is a deformation of bones. Otherwise, nitrate is excess nitrate is present, that it may cause blue baby syndrome. That is methemoglobinemia, it's a technical we say. And another, some minerals, some inorganic matter, even though presents a small quantity like mercury, lead, and other someone, even small quantity excess, that may cause, that is right, that may cause a neuro effect and brain damage, and kidney damages, especially copper, lead, and mercury. That is, even though right is a presence of 0.01 milligram per liter. And this right organic matter, excess organic matter, that may cause gastro disturbances of human beings. That is one, or diarrhea, another problem. Right. Next, control is a control water. How to control waterborne diseases means, first of all, proper treatment before disposal of, before supplying water to the public. Another one, frequently checking and inspecting along the pipeline, that is possible to, right, and any leakages, that is right, must be sealed and repaired. And another one, maximum the time of laying pipeline and sanitary lines, both maximum as possible as far as away laying of the pipelines. In case any doubt in rainy season especially, people should be forewarned or advised to the people drink water after boiling, right? More drink water after boiling. And another last one, by creating awareness among the people by conducting environmental health program, we can control waterborne diseases. Right. Next, go to design period. The design period means a life of water supply projects. So in nature, God designed everything, right? Everything designed like this water supply system. And ours is a designed water supply system 20 to 30 years design period. Water supply system, that is depends upon life of the components and availability of funds, and what is the right take a right population forecasting based on future predicting. But our design should be neither too long not too short. Too long, right, is a burden on present generation. Too short, that is uneconomical. That's right. And there are some design periods of components, dams, and generally we design 50 years, and infiltration works 30 years, and pipe, raw pipe carrying water 30 years, treatment units 15, clean water service reservoir 15 years, distribution system underground pipe networks 30 years, and electric motors and pumps 10 to 15 years only, right? There are what are the factors affecting on life of design period. One is life of the component structure, availability of funds, interest on borrowing from the central government or from World Bank, and anticipated rate of population growth. What is population forecast mean? It's predicting future population. What is need predicting future population mean? So once we design 20 to 30 years design period water supply system, the system should have capable to carry the water without any affecting. So that's why our design should be not only the present, our design should be future next 20 to 30 years. For that purpose, we have to predict the population next to 20 to 30 years of population of city, any town or city, right? So that is what is right. The future population after certain period is known as population forecasting. So central government every decade is conducted what is quantity population growth. So technically we call census record. What is census means? Census population every 10 years. What is the population growth? That is known as census. So what are the factors increasing in population means? One is facilities, living condition, and its environment, industrial potential, and location with respect to transportation facilities connecting and junction like that, and climate condition. These are the main 4 factors increasing in population any town or city. That is right. One is living condition means, and medical facilities and environment, everything, right? That one, right. There are many methods for forecasting population. They are out of the arithmetic increase in method, geometric increase in method, incremental increase in method, decreasing rate growth method, and graphical extension or simple graphical method, and graphical comparison method, and master plan method, and the ratio opposition method, and the logistic curve method. These all methods is working based on past population data. This is past population since data. This arithmetic increase. This method is a very old method. In this method, very simple. The increase in population per decade to decade is assumed to be constant. This method most suitable for old cities, already such cities. This method is most suitable. In this method, what is formula? Very simple formula. Pn is equal P naught plus Nx bar, where Pn is called predicted population, future population. P naught is equal present population, latest. N is equal number of decades we estimated. X is called average arithmetic mean, or mean, that is known as right. This right form this come to write one question. What is the right year? Past data, census data, 1961, 1971, 1981, 1991 is the data given. What is the population data? This data, based on the data, for 1961 to 1971, how much population increase in population. So right, from just subtracting 1971 to 1961, how much population increment, like that. 1981 to 1971, how much? 1991 to 1981, like that. We write more what is the increase in population, we calculated first. Later, the increase in population, we take the average or arithmetic mean, mean, that is right, 3,45,463. Then we applied in this formula. What is the present population? P naught is called present population, 25,85,862 present population. Then first, what is the latest known? 2011. We want 2021 means how many decade? 1 decade. So P naught plus Nx mean, N is called arithmetic mean, X is arithmetic mean, N is equal decade, 1 decade, right? So then what is the P 2021 population, how much? Forecasting 2031 population, how much? 31, what is the right number of decades? 2. Present 2011 to 2021, 1 decade. 2011 to 2031, 2 decades. 2011 to 2041, 3 decades. So that's why just is n value is increasing, 1 2 3, n is equal, right? That is called decades. Number of is represent number of decades, right? This process calculation of arithmetic increase method, right? Then come to right next one, incremental increase method. Missing incremental increase method. In this method, the percentage increase in population will not assuming like constantly, like geometric. There is another one method, geometric method. In geometric method, the incremental increase in population, the percentage increase we assumed constant. In incremental increase method, we are not assuming like that. Just that is the future growth increasing or decreasing depends upon the incremental increase in the past is positive or negative. So this is the formula. Pn is called P naught plus Nx bar plus N into N plus 1 by 2 Y bar, where X bar is called arithmetic mean, Y bar is called incremental increase mean, N is called number of decades, P naught is called present population, right? There are some problem. Very simple. This same like arithmetic increase method. Population. What is right? Increase in population every decade. Right. Here come to right. In incremental increase, already is increase in population. In increase in population, how much is right? Incremental increase. So right, just we subtracting, right. In this one is how much increase. From this one is how much increasing. From here to increasing or decreasing. Right, this is this population is decreasing, so the incremental increase is decreasing, like that. We calculated, then we take the average value. Y bar is average, right? This is called average. We take, right, this average value. Maybe you get positive or negative, that you get positive or negative. So this is a apply formula. Pn is called P naught plus Nx bar, N into N plus 1 Y bar, where X is called 1 decade, Y bar is called, right, this value is Y bar, this Y bar, right, N into N plus 1, like that we calculate. Right. And the decreased rate growth method, the increase in population every year decreasing. For example, right, in the 2010 population, 2010 to 2011 population increase 20,000, but 2020 to 2030 population increase 6,000. So the rate of increase in population is decreasing. That time we applied this formula, decreasing rate of growth method. In this method, the average decrease in the percentage increase is worked out and is then subtracted from the latest percentage increase for each successive decade. This method, however, applicable only in cases where the rate of growth shows a downward trend. That replaces right. Simple graphical method. This graphical extension method. Here, past population data and population x-axis is called year and y-axis is called census year, x-axis, y-axis is called population. Just is we draw the graph based on past population data. Then the graph is extended simply. Then we can predict the future population based on that one. This is right. Very simple graphical. Based on given data, we calculated right data up to 2011 data we know. We drawn the graph. This graph is smoothly extended. Then if you want population 2051, then we calculated what is the population, right. So 2021 we required, then what is the population? 2031, what is the population? 2041, then simple graphical method. This is based on past population data. Another method, graphically comparison method. In this method, one city is compared to another city, but that city is already a developed city in the first. Based on that one, this graphical comparison method we calculated. This right given data, city A, city B, city C. This already is a past population data. Based on this data, we can write already. So our population already is reached in the 1980. 6 lakhs, for example, is 1980. We want right now what is a similar character. We checking the similar character of city. Then what is the 2010, 2021 population? We can easily calculate from this graphical comparison method. This master plan method. So 25, 30 years for the city. Then just whatever, right? Based on past population data, we can data next feature 20 to 30 years, how much area is developed, how much population we can increase, we can easily predict based on area. This one master plan method. This is logistic curve method. This curve, based on logistic curve we can calculate it. This is this curve shape, S curve is known as logistic curve shape. This right easily we can calculate by using logistic curve method. Already first the city initially when the time starting is that the rate of growth is high because of more opportunities. At the same time at a certain period this saturation, this is constantly increasing, then the increasing rate is decreasing, right? This rate is logistic curve method. These formulas, logistic curve method formulas, right? Then demand of water. Next one is demand. Public demanded for various purpose. That is a duty of engineers to supply water, sufficient water to the public based on their demand. This is daily. This demand of water, how to calculate it, right? Demand of water means based on quantity, based on public needs. For example, total per capita demand. First of all, we calculate per capita demand. This per capita demand, annual average amount of water required by any town or city by 365 days into design population. Then you get the right per capita demand. This per capita demand of water based we supply the public. Various kinds of demands like domestic, industrial, and next go to institutional, fire, and water required for compensate losses, right? Come to domestic water demand. It includes our daily needs. What is drinking, cooking, bathing, lawns, gardening, sanitary purpose. This all comes under domestic. Generally, this domestic consumption depends upon status of city, people status, minimum 135 liters and average. But some cities, rich living cities, we supply 220 to 200 also, generally we measure liter per head per day for middle class living people. That is right. This equal is a varying consumption, 50 to 60% is varying, that one. For example, under normal condition, an average Indian per capita demand, these are 135 liters per person per day. Drinking 5 liters, cooking 5 liters, bathing, washing clothes, washing utensils, washing, cleaning of houses, and flushing of water closures. This requirement of water on based on normal condition is required 135 liters. But wherever go to some rich people required more quantity of water for washing cars and maintaining lawns and gardening and some flushing of water closets instead of Indian water closets. That time required more quantity of water, so automatic the quantity of water demanded 200 liters, this way. So industrial needs, for industrial we supplied industrial needs in case any industry is present within the town or city. That water cities demanded based upon 50 liters per head per day on account of industrial needs. Otherwise we calculated separately based on manufacturing. For example, based on manufacturing, any town or industry is present, automobile industry, for manufacturing any vehicle required 40 kiloliters. Depends upon one vehicle, that is if we require more per day 10 vehicles are manufacturing, 14 to 10 kiloliters required into distilled fat, like that. These are some many industries, depends upon industries, based on industries for production how much quantity of water required. This slide shows. Alright, next one, institutional, commercial. Commercial purpose, like any institutions or offices, like that, commercial, bus stand, railway station, hotels, restaurants, is all come to institution and commercial. To meet this demand, we added 20 to 50 liters on per capita demand. Otherwise we calculated separately. So next one is demand for public uses, public toilets and maintaining public parks, gardening, washing and sprinkling on roads, use in public fountains required some quantity of water. So that's why we added 10 liters per head per day on account of per capita demand. Otherwise we calculated separate. Then fire demand. This fire demand is separately we stored water, is not a daily demand. Whenever fire is occur, then we use that water for firefighting purpose. Otherwise, if you not control fire properly, severe damage in thick populated and commercial area and industrial area. That's why compulsory in any town or city for firefighting purpose, some quantity of water stored separately. That water is known as fire demand water. We use some different various kinds of empirical formulas, and Kuchling formula, Q is equal 3182 root P, where P is called population in thousands, where Q is called quantity of water in liters per minute. Freeman's formulas is another formula, 1136 P by 10 plus 10, where P is called population, Q is called quantity of water. And National Board of Fire and writer's formula, this for Q is called 4637 root square 1 minus 0.1 root P. That one, root P. P is called, where P is called population in 1000, Q is called liters in minutes. Water demand required for thefts and losses. There are some losses and some private unauthorized connection purpose. We added some water, 55 liters per person per day on account of per capita demand. So what is per capita demand means? This is annual average amount of water required by one person. and include the domestic use, industrial and commercial, public, everything, right? This one. This is the right process calculating per capita demand, total quantity of water required by town or city per year by design population into 365. We get the liters per person per day. This is an average. So this is varying place to place and location to location. Right. Right. This is right. Per capita demand based on domestic purpose, an average 135, industrial is 14, public is 25, fire demand 15, on losses wastage 55, and overall total 270 liters per capita per day. This mean required to meet all needs, not only domestic point of view. So any town or city means that city is not only residential houses, there are many commercial houses, industrial, and there are public parks and fountains, everything. So to meet all needs required minimum 270 liters per capita per day, right? Then what are the factors affecting on per capita demand, this 270 liters per person per day? How is varying, right? Means one is size of city. If a big city, the per capita demand of water required more than small cities, because in big cities you have to maintain more parks, more public fountains and public toilets, like that. So compulsory required more quantity of water when compared to, right, small cities. And climate condition, you know how warm climate required more water, and cool or cold climate is required less quantity of water, like Bangalore is required less quantity because cool climate. When you go to hot climate, Chennai required more quantity, that is right, hot climate. Like types of habits of people are the rich, medium, and labor, right? Rich people require more quantity of water because of they require more quantity for maintaining lawns and gardens, washing vehicles, like that. And middle people required medium quantity, like 135 liters, and slum area people require less quantity, 100 liters sufficient per day per person per day. Then next, industrial and commercial activities. If more industrial and commercial activities require more quantity of water when compared to less industrial and commercial activities. And quality of water, if more quality, good quality required, people demanded more quantity of water. For less quality, people are demanded less quality, less quantity. And pressure in the distribution system, if more pressure required more quantity of water when compared to less pressure. And cost of water, if cost is high, demand is less, and cost is less, demand is high. And development of sewerage facilities, if more sewerage facilities is available, required more quantity of water to maintain, right, all sewerage facilities along the sewer lines. And types of water supply system is continuous system water supply required more quantity of water when compared to intermittent system. Intermittent means only supply morning 1 hour and evening 1 hour. And policy of metering and method of charging. You follow only thumb rule. Thumb rule mean, for example, morning only how much quantity of water use, we charge only monthly 40 rupees or 50 rupees for house. That is right. We go to right method of charging. Otherwise, we fit the meter for each houses. That time consumption is different, right? And this fluctuations in water demand, variations. Morning time, peak hours, right? Morning is required more quantity of water, and reaching the peak up to 8 to 10, 8 to 11. And again is the decreasing rate of demand, again increasing in the evening, and again at late nights decreasing rate of demand. This is right. So increasing in demand is the average demand, right, per day, right? This right is average demand. Fluctuations, maximum daily demand 1.8 times average daily demand, because in Sunday, festival day, the quantity of required is more, so that's why 1.8 times is more required when compared to normal day water. Maximum demand of hourly demand, that is 2.7 times average annual average hourly demand. Maximum hourly demand is equal 2.7 times annual average hourly demand, right? This is a seasonal variation, daily variation, where there are various factors. Seasonal means summer and cold. Daily variation means Sunday, festival day required more quantity of water, right? And hourly variation, morning time is activities is more. Again, evening time activities require more quantity of water when compared to afternoon and late hours of the day. So, to supply water adequate quantity at the peak demand, to meet the fluctuation, the water supply pipes, serves, reservoirs and distribution pipes must be properly proportionally designed, right? The effect of monthly variation influence the design of storage reservoirs, and hourly variation influence the design of pumps and sewer reservoirs. This is a fluctuation, right? Thank you.